Because it's you did the work, it would be the initial minus the final.
The initial minus the work did by the
So
force.
it's the initial potential minus the work.
Yes.
Okay.
Yes.
So it will always be positive.
If you consider it as this is a spring, for example, it moves from 0 to 3. So in this process, this force is negative, right? Because it's pulling back. But it's conservative because the energy is stored in the spring.
Okay.
But the work it did is negative, right?
Mm-hmm.
If it moved from here to here. But this negative work, for example, negative 9, will convert into 9 in the potential energy, right? So you just need to, that's the difference.
Okay.
Okay. You just need to remember it's minus
Mm-hmm.
the work did by the conservative. But if you draw a graph to see the spring, you will understand why it's minus. And then the second one, object from A to B. 1 kb object of 1 kilogram is acted upon a single conservative force with each d during this motion. At point A, the speed of particle is 6 meters per second, and the potential energy associated with the force is 50. Okay. What is the potential energy at point B? So we don't know the speed here, the velocity. Actually, this 6 meters per second doesn't mean anything. We know the work did by the force, and it will all convert into potential energy. So it's 50 minus, right? It's 9. So it's 90. Yeah, it's C.
Okay.
It's the same as the first one. And then number 3, so it's the same. Excuse me. It's 2 kilogram. Radius is 1.5 meter. The maximum angle is 30 degrees. What is the speed of this object at the bottom? for this kind of question is, that's the top, the maximum position it can go to, right? And at this point, the velocity will be 0, because it stopped there and then go down. If we analyze energy, if we consider here as 0, we need to calculate the height here, right? That's the potential energy. So mgh, that's the potential energy. When you go to the bottom, the height will become 0 because it goes to the bottom. So it has no potential energy anymore. All this potential energy converted into the velocity, the speed, will be, right? I can move this one up here. And then this h is, because we know this line is 1.5, right? It's the radius. And then we know this line is 1.5 times cosine 30, right? Here is 30 degrees. So this line is 1.5 minus 1.5 times cosine 30 degree. Right? So that's the h. So if you plug in this number into here and then calculate, you get velocity equal to 1.98. So approximately 2 meters per second. So it's a.
Because to get the pendulum, to get the height in any pendulum question, it would be want to be L 1 minus cosine. That's the formula.
Yeah, L can take you can take out the L, will be 1 minus cosine,
Cosine.
right?
Okay, yeah. That's the formula
Yeah,
for any pendulum
yeah.
question for height. Okay. We keep going.
And number 4 is another pendulum question. And the length L is 3 meters. The speed at the lowest point is 6 meters per second. The question is, what is kinetic energy at the instant when we don't know where is the maximum? Let's say here is the maximum. But it asks you in the middle, when it has an angle